Insulated cable glands serve several critical purposes in electrical installations. Firstly, they provide electrical insulation between the cable conductor and the metal enclosure. This prevents short circuits and electrical shock hazards, ensuring safety and reliability. Secondly, insulated cable glands offer cable strain relief. They secure the cable in place, preventing excessive bending or pulling on the connections, which can damage the conductors or terminals. Thirdly, moisture protection is another key benefit. These glands seal the cable entry point, preventing moisture from entering the enclosure and protecting the electrical components from corrosion and degradation. Fourthly, chemical resistance is provided by insulated cable glands, as they are made of materials that resist chemical corrosion, ensuring the integrity of the cable and enclosure over time. Fifthly, environmental protection is ensured, complying with industry standards. These glands protect the cable from environmental factors such as dust, dirt, and ultraviolet radiation, maintaining its performance and longevity. Insulated cable glands are commonly used in various applications. Electrical enclosures, such as switchgear and transformers, utilize them to ensure electrical insulation and moisture protection for cables entering or exiting the enclosure. Control panels and instrumentation systems rely on insulated cable glands to isolate and protect cables connecting sensors, actuators, and other electrical devices. Hazardous areas require these glands to meet explosion-proof requirements and prevent the ignition of flammable gases or dust. Outdoor applications benefit from the protection these glands offer against environmental factors, ensuring reliable operation in harsh conditions. High-voltage installations use insulated cable glands to provide additional insulation and voltage protection. In specific projects involving single-core main feeder cables between switchgear and transformers, insulated cable glands are employed for several important reasons. Electrical insulation is paramount to ensure the safe and reliable transmission of high voltage between the transformer and switchgear. Strain relief prevents any mechanical stress or damage to the cable due to vibrations or movement, maintaining the integrity of the connection. Moisture protection prevents moisture from compromising the electrical integrity of the cable connection, ensuring consistent performance. Fire resistance is another critical factor, as the use of insulated cable glands helps meet industry standards and ensure the safety of the installation in case of a fire. These glands help to contain any potential fire, minimizing damage and protecting personnel. The selection of the correct type of insulated cable gland is crucial for optimal performance and safety. Considerations include the cable type and size, the environmental conditions, and any specific industry standards or regulations. Proper installation is also essential to ensure that the gland provides effective insulation, strain relief, and environmental protection. Regular inspection and maintenance can help identify any signs of wear or damage, allowing for timely replacement and preventing potential problems. By understanding the reasons for using insulated cable glands and their appropriate applications, you can ensure the safety, reliability, and longevity of electrical installations. Using the right glands in the right places and circumstances are critical to the overall construction and safety of the system. Factors to consider when selecting insulated cable glands include the material of the gland, its temperature rating, and its resistance to chemicals and other environmental factors. The gland should be compatible with the cable being used and should provide a secure and reliable connection. In hazardous areas, it is important to use cable glands that are certified for use in those areas. These glands are designed to prevent the ingress of flammable gases or dust and to contain any explosions that may occur. The use of insulated cable glands is an important part of ensuring the safety and reliability of electrical installations. By providing electrical insulation, strain relief, moisture protection, chemical resistance, and environmental protection, these glands help to protect cables and equipment from damage and ensure that they operate safely and reliably. In the context of single-core main feeder cables, the use of insulated cable glands is particularly important due to the high voltages and currents involved. These cables are often used to connect switchgear to transformers, and they must be able to withstand high levels of electrical stress. The insulated cable glands provide an additional layer of protection, helping to prevent electrical breakdowns and ensuring the safe and reliable transmission of power. In addition to their electrical and mechanical benefits, insulated cable glands also offer a number of practical advantages. They are easy to install and maintain, and they can be used in a wide range of applications. They are also relatively inexpensive, making them a cost-effective way to improve the safety and reliability of electrical installations. The project that you are involved in utilized insulated cable glands, and this is considered a crucial component of the electrical system, helping to protect cables and equipment from damage and ensuring that they operate safely and reliably. When selecting insulated cable glands, it is important to consider the specific requirements of the application. Factors to consider include the cable type and size, the environmental conditions, and any applicable industry standards or regulations. It is also important to choose a cable gland that is compatible with the enclosure being used. The enclosure should be made of a material that is resistant to corrosion and should provide adequate protection against environmental factors. The cable gland should be properly installed to ensure that it provides a secure and reliable connection. The gland should be tightened to the correct torque setting to prevent damage to the cable or the enclosure. Regular inspection and maintenance are important to ensure that the cable glands continue to function properly. The glands should be inspected for signs of wear or damage, and they should be replaced if necessary. By following these guidelines, you can ensure that your electrical installations are safe, reliable, and compliant with all applicable standards and regulations. The use of insulated cable glands is a best practice that can help to prevent electrical accidents and ensure the long-term performance of electrical systems. In summary, insulated cable glands are an essential component of electrical systems, providing a range of benefits that contribute to safety, reliability, and performance. Their use is particularly important in high-voltage applications, hazardous areas, and outdoor environments where cables are exposed to harsh conditions. By selecting the right cable glands and installing them properly, you can ensure that your electrical systems operate safely and reliably for many years to come. Remember to always consult with qualified electrical professionals and adhere to relevant industry standards and regulations when working with electrical installations. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Always de-energize circuits before working on them and use appropriate personal protective equipment such as gloves and eye protection. By following these safety guidelines, you can minimize the risk of electrical accidents and ensure that your electrical installations are safe and reliable. Furthermore, the choice of insulated cable glands depends heavily on the type of cable being used. For instance, single-core cables often require glands that can handle the specific stresses and movements associated with their construction. Multi-core cables, on the other hand, may benefit from glands designed to provide additional support and strain relief to each individual conductor. Considering the cable's construction and material is vital for ensuring a secure and long-lasting connection. The environment in which the cable gland will be used plays a crucial role in its selection. In corrosive environments, glands made from materials like stainless steel or specialized polymers offer superior resistance to degradation. High-temperature environments necessitate glands with appropriate temperature ratings to prevent premature failure. Similarly, in areas prone to vibration, glands with enhanced mechanical strength and vibration resistance are essential for maintaining a reliable connection. The importance of proper installation cannot be overstated. Incorrectly installed cable glands can compromise the entire system, leading to potential electrical faults, water ingress, or even explosions in hazardous environments. Manufacturers typically provide detailed installation instructions, including torque specifications for tightening the gland. Adhering to these instructions ensures that the gland is properly sealed and that the cable is securely held in place. Regular inspections should be conducted to identify any signs of wear, damage, or loosening of the cable glands. Early detection of these issues allows for timely maintenance or replacement, preventing more serious problems from developing. These inspections should include checking for corrosion, cracks, and ensuring that the gland is still properly tightened. The compliance of cable glands with relevant industry standards and regulations is paramount, particularly in specialized applications such as hazardous areas. Standards like ATIX and ESIX define the requirements for equipment used in explosive atmospheres, and cable glands certified to these standards are designed to prevent ignition sources. Using certified glands in these environments is not only a matter of compliance but also a critical safety measure. In addition to their primary functions, insulated cable glands can also offer secondary benefits such as electromagnetic compatibility (EMC) shielding. EMC glands are designed to minimize the emission and reception of electromagnetic interference, which can be crucial in sensitive electronic systems. These glands typically incorporate conductive materials that provide a path for electromagnetic energy to ground, reducing the risk of interference. Considering the overall system design is essential when selecting cable glands. The glands should be compatible with the enclosure, the cable, and the environment in which they will be used. Factors such as cable entry size, thread type, and material compatibility should be carefully considered to ensure a proper fit and reliable performance. When working with electrical systems, it's crucial to prioritize safety. This includes following all relevant safety guidelines, using appropriate personal protective equipment, and ensuring that all work is performed by qualified personnel. Neglecting safety can have serious consequences, including electrical shock, burns, and even death. The choice of cable glands may also be influenced by the specific requirements of the application. For example, in applications where frequent cable changes are required, glands with quick release mechanisms can save time and effort. Similarly, in applications where cables are subjected to significant movement, glands with flexible designs can prevent damage to the cable and ensure a reliable connection. Selecting the appropriate type of cable gland can also contribute to the overall aesthetic appeal of the installation. Glands are available in a variety of materials and finishes, allowing them to be seamlessly integrated into the design of the equipment. In some cases, custom-designed glands may be required to meet specific aesthetic requirements. Insulated cable glands are also used in renewable energy systems, such as solar power installations. In these systems, cable glands are used to protect cables from environmental factors and ensure the reliable transmission of power from the solar panels to the inverters. The glands used in renewable energy systems must be able to withstand extreme temperatures, ultraviolet radiation, and other harsh conditions. In marine environments, cable glands are used to protect cables from saltwater corrosion and ensure the reliable operation of electrical equipment on ships and offshore platforms. The glands used in marine environments must be made from corrosion-resistant materials and must be able to withstand the constant exposure to saltwater and other harsh conditions. In the railway industry, cable glands are used to protect cables from vibration, shock, and other mechanical stresses. The glands used in railway applications must be able to withstand extreme temperatures and must be resistant to chemicals and other contaminants. In the telecommunications industry, cable glands are used to protect cables from environmental factors and ensure the reliable transmission of data. The glands used in telecommunications applications must be able to withstand extreme temperatures, ultraviolet radiation, and other harsh conditions. In the automotive industry, cable glands are used to protect cables from vibration, shock, and other mechanical stresses. The glands used in automotive applications must be able to withstand extreme temperatures and must be resistant to chemicals and other contaminants. In the aerospace industry, cable glands are used to protect cables from extreme temperatures, vibration, and other harsh conditions. The glands used in aerospace applications must be lightweight and must be able to withstand the extreme conditions of flight. In the medical industry, cable glands are used to protect cables from environmental factors and ensure the reliable operation of medical equipment. The glands used in medical applications must be made from materials that are biocompatible and must be able to withstand sterilization processes. In the food and beverage industry, cable glands are used to protect cables from environmental factors and ensure the reliable operation of food processing equipment. The glands used in food and beverage applications must be made from materials that are food grade and must be able to withstand cleaning and sanitizing processes. Insulated cable glands are a crucial component in various industries, ensuring the safety, reliability, and longevity of electrical systems. The diverse applications and specialized designs cater to the unique requirements of each industry, making them an indispensable part of modern technology. The proper selection, installation, and maintenance of cable glands are essential for maintaining the integrity of electrical systems and preventing potential hazards. They come in a variety of sizes, materials, and designs to accommodate different cable types, environmental conditions, and industry standards. Understanding the specific requirements of your application is crucial for selecting the appropriate cable gland and ensuring optimal performance. With the right cable glands in place, you can safeguard your electrical systems and ensure their safe and reliable operation for years to come.